In a previous lesson, you found out how to find limits at infinity and horizontal asymptotes by basically using your calculator because you got graphs to look at. Today, at the end of this lesson, you'll be able to find limits at infinity and horizontal asymptotes without the aid of your calculator. All right, we know that already how to find a horizontal asymptote. To find a horizontal asymptote, you basically just need to find the limit as x approaches infinity and the limit as x approaches negative infinity, and we'll use that information to find that horizontal asymptote. But in this case, we don't get to use our calculator. So I'm going to give you some guidelines, and I think I'll write them down at the bottom here. And I'll try to point out how it could kind of be common sense, but at some point you may need to memorize it too. I'll leave that up to you. Okay, we would like to find the limit as x approaches infinity of 2x minus 1 over 3x plus 2. You will notice that if I look at the degrees of the two equations, the degree of the numerator and the degree of the denominator are the same because the highest power in the problem is a 1. And they're both 1. Okay, if that happens, so I'm just going to put down here, degrees of numerator and denominator equal each other, then the way that you'll find the limit is you're just going to have the ratio of the leading coefficients. And that will equal your limit. Okay, so for this one, you'll notice that the degrees are the same, and basically that just means they're basically growing at the same rate, but the 2 and the 3 will kind of help them grow a little bit differently. So since the degrees are the same, basically the leading coefficients are just the numbers that are in front of the x's. So my limit as x approaches infinity will just be 2/3, and that's all you have to do for that. Okay, and then it said to find any horizontal asymptotes. Since the limit as x approached infinity was equal to 2/3, we know that there will be a horizontal asymptote, and that horizontal asymptote will be the line y equals 2/3. Remember, we're going to write it as a y equals because it is actually a horizontal line. Okay, this next one, we want to find the limit as x approaches infinity of 8x cubed plus 2 over 4x squared plus 2. You kind of have to think about this a second. If I plug in numbers that are approaching infinity, bigger and bigger and bigger, x cubed is going to go faster than x squared. So the stuff on the top is going to be bigger than the numbers on the bottom, which is going to make this limit equal to infinity. So the next one that I'm going to put, the degree in the numerator is greater than the degree in the denominator. My limit as x approaches infinity will equal infinity because, again, the top is growing greater than the bottom. So I will just put for this one, and I'll just circle that we have those powers. My limit as x approaches infinity is equal to infinity. And since that equals infinity, there's no finite number that it equals, we will put that there are no horizontal asymptotes. All right, let's just keep trying some examples here. You'll notice on this one we have the limit as x approaches infinity of 4x plus 3 over 5x squared plus 7. This time you'll notice if I compare the degrees, this one has a degree of 1, this one would have a degree of 2. So notice, since the degree on the bottom is bigger, the bottom of the fraction is going to grow faster than the top. And if that happens, we'll end up with like 5 over 1,000 and then 6 over 8,000. That number is going to keep getting smaller and smaller and smaller. So, guideline 3, if the degree of the denominator is bigger than the degree in the numerator, then my limit as x approaches infinity will actually equal 0. So on this problem, my limit will be 0. So I'll just put the limit as x approaches infinity will be 0. And in this case, since I did get a limit and it did equal a finite value, I could also say that there will be a horizontal asymptote, and that horizontal asymptote will be the horizontal line y equals 0. All right, this next one is a little bit trickier because you'll notice that we have a square root in the problem. I would like to be able to use the 3 guidelines that I gave you, but it's not set up in the correct form right now. So I'm actually going to use this hint that x is equal to the square root of x squared. Basically, all that means, if the bottom is under the square root, I'd like to have the top in the square root also. So I'm going to put a square root in the problem. But remember, the only way for me to really not be doing anything is if I put a squared, because you'll notice the square and the square root cancel each other out. So I'm allowed to do that. It's mathematically okay. All right, now since I have that, since they're both underneath the square root, I can actually write it just as one big square root sign. So I'll have x squared over x squared plus 1. And now you'll notice, since they're both underneath the square root sign, I can actually use the properties that I just talked about. So I look at the degrees. The degree in the numerator and the denominator are both the same, and if they're both the same, the limit will be the ratio of the leading coefficients. And in this case, the leading coefficients would both be 1. So my limit, as x approaches infinity, is going to be 1 underneath the square root sign. I have done absolutely nothing with the square root sign yet. So now I actually need to finish it by finding the square root of 1. So the limit as x approaches infinity, the square root of 1 is just 1, so my limit will be 1. And now since I did that, because I'm looking for horizontal asymptotes, my horizontal asymptote will be the line y equals 1. Okay, let's go ahead and take a look at example 5. I chose one more example, like example 4, because I thought for some people it probably went whoo, right over your head. So we're just going to do that one more time. All right, I'd like to use the guidelines, the 3 guidelines about the degrees in the numerator and the denominator, but I can't right now because one of them is under a square root and one of them is not. So to make one under the square root, let's just put it under the square root, but to undo the square root, then we have to square. Please notice that when I square it, I am squaring everything inside. So if I rewrite this, I will have the square root of 16x squared, because I have to square both parts, over the square root of 2x squared minus 3. Now since they both are under the square root, I can write it as one big square root. So 16x squared over 2x squared minus 3. Now I can look at the degrees. The degrees are the same, so I can take the ratio of the leading coefficients. And so when I do that, 16 divided by 2 is 8, but actually that's not fully right because I still have that square root sitting there. So the limit as x approaches infinity is equal to the square root of 8. And since I found a limit, I can then also say that my horizontal asymptote is going to be the line y equals square root 8. Right? Example 6 we will be saving and doing in class together. So hopefully now without your calculator you can find the limit as x approaches infinity and then also use that information to find horizontal asymptotes.